That's now the second hour.
Oh, that worked.
What else can you do?
No.
I'm not going to
Friday. I'm not on the weekends. I'm not.
I'm not going to complete.
Okay,
I'm not going to.
let's get started, inshallah. So yesterday I taught you guys and worked with you on letters A, B, and C, and we saw that this question can get pretty tricky because of the units, right? And finally we're gonna do letter D and then move to a new question, and I'm gonna try to see if I can turn something over to you for the next question. So letter D says, again to remind you, there was a gravel plant and it was processing the gravel that was coming in. That was called unprocessed gravel, and then it leaves basically at a rate of 100 tons per hour. So now we are asked the question, so in this whole process of gravel coming in and gravel leaving and stuff like that, what's the most amount of unprocessed gravel that was at the plant during the hours of operation on this workday? And then it says justify your answer, okay? So, I'll directly teach you this. And yes, it is a calculator problem. But what's a word in there that you guys can relate to and you're like, maximum, right? So, write down that for 2013, the word in part D is actually referring to the absolute maximum, alright? I know it doesn't come with the word absolute, but that's what it's implied there. They're saying, what's the most amount of gravel that was at that plant during these hours, right? Because we know it was coming in and leaving at the same time. So, when did it get the highest, and then that pile started to diminish after that, alright? So, do you guys remember anything about the process of finding absolute maxes or absolute mins? Alright, so write down that we're going to use the candidates test. So let me remind you really quickly about the candidates test. Basically what happens is you take a function, you take its derivative, you set the derivative equal to 0, you find the critical points, and you make a note of the endpoints. You make a table. That table is going to comprise of basically all of your endpoints. So you have 2 endpoints and all of your critical points. And then you're just going to be checking around those to see what are the function values at every single one of those points. So you've done this process before. This is an application of the process of absolute maximums. Okay, so let's go ahead and start. The variable that we have is going to be the letter T instead of X. So you're going to go ahead and write down T and make a column. Then you're going to make an equation for the amount of gravel that's going to be at a time in the gravel plant. Okay, and here's how it goes. How much was there to begin with? Alright, so 500 added to. What time did the thing start at? 0. Now this one, at the top, you're going to keep changing it. You'll keep altering it, right? Based upon the time that you get, you'll keep altering the top of the integral. Because you want to know, okay, from 0 to 3 hours, how much did I have? 0 to 4 hours, how much did I have, right? So leave the top as t. And you're going to take the rate in. The rate in was called g of t. And then you will subtract from 0 to t the rate out. How much was the rate out? 100. So this is going to be your integral. Or should I say sets of integrals. Most folks will realize if you have the same limits on 2 separate integrals, you can converge them to make it one integral. So you can just call it 0 to t g of t minus 100 as opposed to having 2 separate integrals. Yeah.
So how are we supposed to know to use the formula of the total amount instead of just GT?
because that would have told you just how fast it's arriving to the plant. That doesn't exactly tell you when was it the most amount that was at the gravel plant, right? So if they had said, what's the maximum rate, then you would have taken that instead of equal to 0. So, this is why I put this on the board first. You begin by taking a derivative and set it equal to 0, because you need those critical points. But yesterday we had this lengthy discussion, and one of you came up to me later and said, I don't get that part there. Once again, this is already a rate, okay? That's already the derivative. How do we know that? Because the units were tons per hour. That stands for a derivative then. But at the same time, there was things that were leaving, so you also have to consider that piece over there. So it's not exactly like this, it's more like f of x and g of x, and it's more like you taking a derivative of each one of them, and then setting each one of them like that equal to 0. Okay, that's really what's happening. So what we do is we first write down g of t minus 100. Again, just to help you out, this is rate in, this is rate out. All right, they're both rates, and you're trying to find the critical point. Where was that part where the in and the out matched? Just for that moment, they must have been the same. So for that, we say it's equal to 0. Now here's how you're gonna use your calculator. You're gonna pick up a calculator, and in your calculator, you're gonna put the g of t equation into your y1. You probably already have it. You're gonna put the 100 into your y2. You're gonna reset that window from 0 to 8, so x min, x max, make it 0 and 8. Y min, y max, you have to play around with it. If you don't see like the line, that means you're too low, okay? You need to go higher. You definitely need to go to 100, right? In the maxes for y. So maybe go like 120, 130. So you're trying to find those intersection points basically. But you write those first because those represent the critical points that we're gonna need.
Yeah.
I did 0.
So you can write g of t minus 100 and find the zeros, or usually what people do is they find g of t in y1 and 100 in y2, and then they just find the intersection instead. It'll get you the same answers. Yes.
Y0.
Yeah, of course.
The intersection?
Please.
4.923.
Okay,
Is it because my mom, I'm in the grades?
4.923. Go on, Hais.
4807.
480. Okay.
Wait, so, wait, sorry,
the
what did
window.
we did
That's
y1
the
minus
window.
y2?
Exactly. We did y1 minus y2, and you can just find its zeros.
Oh.
Or the second option is to put y1 equal to
And
y2,
find the intersection.
because you just move the 100 over to the right side and then find the intersection
Okay.
instead. You have two options here. Whichever one you choose, you should get the same answer that Hadis just gave us. Please make sure you can do this yourself. Don't give it to your friend and be like, he'll figure it out, alright? This represents the critical point, thank you, okay? This is the critical point. So because this is the critical point, and that's a crazy looking number, just go ahead and define it as any letter. I'm gonna go ahead and call that A from here on out, okay? So, here's how the process of absolutes work, okay? It's just this right here. They're just applying it, and an application of it is a lot crazier than just learning it from the basics. So, you're gonna consider the endpoints. What's the left endpoint of this whole process? 0. So you're gonna put a 0 into your candidates table, alright? That, you should realize, is really just asking you the initial condition, okay? So how much do we initially have? 500. Or if you wanna really push it, I mean, you could plug into it and realize that this is gonna give you 0 for the other two. Okay, now, here is where you really need to put in the work, okay? Using that time, because it's a critical point, you gotta figure out how much was at the plant at that time. So you're gonna be plugging the t value right there, as well as right there. You've already stored this into your y1 and your y2, so there's no sense in rewriting it, just recall it instead when you're finding these values. So in your calculator, you're typing in 500 added to the integration from 0 to a of basically g of t minus 100 dt. And you're telling me how much amount?
635.376. Oh, wait. Oh, it's okay to have the integral separated?
Yeah, that's the same thing.
Oh,
Why is my calculator loading?
did anyone get that?
Yeah,
That's so low.
6:30.
It just takes forever to compare it, and it's like you're still just one.
Can I see? Because you integrated from 0 to 500.
No.
How does getting everything correct today, guys? Must have had your morning coffee.
Yeah, I did.
Very good.
Oh, I didn't add that.
And now do we do 8?
We did 8.
8.
Yes. Sorry, I heard 8.
Is that the last one or?
someone could.
That would
There's
be
only
the-
one critical.
There was only one critical point. How did someone give me one value?
Oh, I can.
You, Mason,
I got the same as
We're gonna write it all for you so that if
Oh, this has to be different.
525.551.
You got that, I got that, you got it.
525.5.
Okay. Now ask your questions.
Where'd you get your information from?
They said for the entire hours of operation, the hours of operation were 0 to 8. So there's your and then your max. Other questions? Okay. It says justify your answer. So please don't stop here, okay? Do they want the time that the maximum happened or the maximum itself?
Maximum itself.
Okay, so here it goes. The maximum
Oh, you don't say absolute.
amount, no, it's implied that we're talking about the absolutes here.
Okay.
The maximum amount of gravel at plant occurs at t equals a, and it is 635.376. Okay? So that is the flow rates problem. Yes, Mason?
Where did you justify your answer? Doesn't it imply you have to use some sort of theorem? So do you have to specify?
This is actually called the extreme value theorem, but because of the way that you structured this,
And it just needs to be fine.
it's fine, okay? If you really wanna push it, you can say by the EVT, but that's just like an unnecessary flex, okay, so, right. Alright, so, before we move on, if you just understand how these things are structured, you don't need me to lecture on years and years of questions, okay? So please focus on the understanding of it, not just like what's going on the board over here. And second, I just want you to think like, if you didn't understand the water bottle example, because some of you are staring at me like, who makes holes in the bottom of a water bottle, okay? So pretend you're, you don't have to be sitting in the tub, but let's suppose you're looking at a tub of water, right? Like in your shower, you're looking at a tub of water, right? And let's suppose that somebody leaves the thing, what's the thing called that you put in the plug, right? So you notice that there's some water that's still in the tub itself. That's like your initial condition. Now, you turn on the shower. So when you turn on the shower, there's water that's now entering into the tub. And at some point you're like, well, this is getting really high, right? We've all done this as little kids. You're like, I gotta pull this thing before mom finds out, right? So you pull that thing, and now it's also draining. So the idea was, now there's water coming in and there's water draining, so nobody's guaranteeing that it's gonna start to go down. Maybe the water coming in is coming in really fast, So it's actually gonna continue to go up. But what we're saying is eventually it does go down in this scenario, okay? That's because of the function that they gave us.
I
Yeah,
have a question, so when we were plugging in, why didn't we use, like, I know we're learning about flow rates and stuff like that, but why didn't we use that, the equation like they gave us about the 90 plus 45 cosine, cause at first that's what I was gonna plug it into, but then I saw what you
I
did, like,
asked
well,
the
then
same
why don't
thing.
you plug it
it's a
into?
great question.
They're asking for that.
They want an amount, okay? And plugging into that would tell you the rate at those times. How fast was it entering and stuff, so, and that's what a lot of people think is.
Why for the critical points did we subtract that 100? Because I would have just done GFT equals 0.
Again, that's the problem, because you're looking at this whole scenario entirely. If they're talking about the maximum amount of unprocessed gravel that's at the plant doesn't just contain stuff that's coming in, it also has to account for stuff that's leaving. That's what I'm saying, you're looking at the tub of water, and you're looking at the maximum amount that occurs in the tub of water. So you can't just focus on the water that's coming in, you have to also consider the one that's leaving. And that's why you have to also consider the rate out when you do this, and finding the critical points. Yes?
So is that intersection where they're both 0, and like, if we didn't have the initial condition, there would be 0 gravel there? So is that why we're adding it to the initial condition? If, for example, like if the 500 didn't exist, and both the rates were the same, that means we would have 0 gravel at like that specific
Yeah,
point.
here?
Yeah.
Yeah, definitely. Sometimes you just assume it if they don't mention it to you, okay? Like 1 year there will do it, but there's like fish in a pond, or nobody's gonna go and search up how many fish are in this pond before, you know, they start reproducing and stuff. So you're like, whatever, just pretend like it was whatever number. Then they won't ask you any questions about stuff that, you know, would need that certain condition. Okay, 2015, number 1. I could use every single minute that I have, so go ahead and start with it. Notice at the top it says Calc AB and Calc BC, so you don't just forget most of these topics, you have to remember them for next year too. If you're with me next year, they test you on the same exact thing, it's the same question for both groups, right? So go ahead and get started. You guys are now prepared to do all of it, okay? So I think if I start writing, I might get through like maybe 1 or 2, so I'd rather just hold off on doing any other writing. I'll show you the solutions to what you're done with. Again, as you're doing this, you want to focus on figuring out when you're reading this, where's the rate in, where's the rate out, is there, and what is the initial condition, and then you start with the questions, all right?
So for the rate out, they gave us also like a rate this time. So
Yeah.
Good, well, this is also a rate, it's called a constant rate,
Oh.
okay, that's a function, so it doesn't just like do one thing. Sometimes it's slow, sometimes it's fast, like that, alright?
Oh, yeah, right. Yeah, that's a total amount, but.
It's just asking how much flows in.
No, it's saying how many, it from the per hour, like how much they flow, oh, it's asking how much flow.
It's not like counting for the hour.
How do you know that?
Because it says into the pipe,
How much is it?
it doesn't work this
So
way.
we just do the RT thing?
Let's try to get through A and B at least. We'll definitely pick up on this. Oh, I don't know, tomorrow. Tomorrow is no school. Monday.
well, sorry, really behind. Are we
Uh,
overly behind?
You know, at this point, I think I'm more concerned about the people who are absent and kind of lost as opposed to.
Are you recording?
Yeah, we're recording, right? You turned it off.
hard to watch.
Sister, we can record everything.
It's not the same.
It's not about that. You have to be here live. It's like looking at a picture of a burger versus actually
And also,
eating a
especially with
burger.
FRQ.
Sorry, I'm a little hungry.
It's so tedious to watch back to FRQ. It's very difficult to do.
So the first one is 76.570 cubic feet.
Yeah.
Let's take one more minute,
I want the rate.
then we'll have a quick 2-minute discussion.
what you do
and
could be.
That'll be it. While you're working, keep in mind we have a quiz on Monday.
Quiz on Monday.
Oh, we did this one Davis right?
Quiz on Monday.
Uh,
Quiz on Monday.
no wait, is
I
it not
know,
a
it's
one?
on,
Oh, we did the
it's
derivative
on,
of it.
velocity.
We did the derivative at
It's on
the amount.
velocity.
We did it, the question before I left. You take the derivative of
The
it
only,
at,
the only thing I'll do
of
there.
RTF.
So would you do the?
No, actually, the quiz is on linear motion part 1 and
They're not capable
I
of
did it
doing
before,
that.
and
It's
it's
just
non-calculated?
You know the
No,
free
no,
response
no.
packet?
No,
Go over
This
that.
is the way, which is because it's saying the amount. The question goes over how much the rate is.
Yeah, in order to say the amount, you have to talk about the.
I would, bro, how many times have you gotten the Paramount physics? Like one time. I've gotten the Paramount physics at least 4 or 5
Okay,
times.
real quick. Rate in or rate out?
Rate
Rate
in,
I
in.
taught.
rate out.
I said it.
Initial condition? 30. Okay, here goes. They're gonna grade you on one, the integrand. Again, I know it's from 2015, but it hasn't changed much. So one on the integrand and one on the answer. If you only give the answer now, they actually will not give you the integrand point. They used to be okay with it, they're not okay with it anymore. Okay, letter B. We might need to rediscuss this on Monday. If you want to figure out if the amount of water in the pipe is going up or going down, again, they use the word increasing or decreasing. That means you need to study the rate. Now, having said that, you have to study the rate. Are these already rates?
Yeah.
So all you needed to do, listen, all you need to do is plug the number 3 into both of them. I know they look like functions, but look at their units. Those are rates, okay? They're just been rebadged as functions. So all you had to do, again, this is, I think, where I've never really succeeded 100% with my students to get them all to get this correct. But you just need to show that, look, one of the rates is less than the other. Make sure you tell them what it is. Make sure you tell them what it is. And therefore, the amount must be decreasing in the pipe, okay? They actually subtracted them, got to a negative answer, and said, look, that's a negative rate. So overall, it's decreasing in the pipe itself, okay? I guess we'll pick up with C and D on Monday, alright? That's like right on.